Welcome to this video. We're going to talk about everyone's favorite subject, converting. That's so much fun. We should get a few more smileys in here, because who doesn't love converting? Okay, you're probably detecting some sarcasm in my voice. Converting, this is one of those topics that many people feel like they never really understand, and there's different rules, and you have to worry about different types of conversions. So we're going to try and explain this one way, using one principle. And what is that principle? Converting is no different than multiplying by 1. Every instance of conversion is doing exactly this. So let's take a look at some examples. And let's try thinking about multiplying by 1 as we answer these questions. Okay, convert 11 centimeters into meters. First, and then they tell us centi is a prefix that means 10 to the minus 2. Now this prefix could apply to meters. You could put a meters here, 10 to the minus 2 meters. Or you could put, newtons, centi-newtons, 10 to the minus 2 newtons. You could put joules, unit for energy. A centijoule would be 10 to the minus 2 joules. It doesn't matter what you put in, because anything could go. But we're working with centimeters, so let me write down centimeter. 1 centimeter is 10 to the minus 2 meters. Okay, let's get started. You take the value that you want to convert, 11 centimeters, and you multiply by 1. That's what converting is. But instead of multiplying by literally just the number 1, we're going to multiply by a fraction that equals 1. Now every fraction is equal to 1 if the numerator and denominator are the same. So 2 over 2, that's equal to 1. 6 over 6, that's equal to 1. 1 plus 1 over 6 thirds. That's 1, because the numerator and denominator are equal. Okay, so I need my numerator and denominator equal. But what do I put up here? What do I put down here? You look to the equation. One of these things will be the numerator. The other will be the denominator. How do you figure out which goes where? You look at the units. 11 centimeters is the same as 11 centimeters divided by 1. So the 11 here is in the numerator. Okay, you want to get rid of centimeters, you want to convert into meters. That's what this says. So you need meters up top, you need centimeters on the bottom, and what do you have? You've got 1 centimeter is equal to 10 to the minus 2. Right now, my fraction is incomplete because they're not equal, the bottom and the top. To make the bottom and top equal, I say, 1 centimeter, that's what the left side has, is equal to 10 to the minus 2 meters. And why did I want centimeters in the denominator? Well, because now I can cancel centimeters out. Centimeters over centimeters is just 1. And I'm left with meters as the unit. So the answer would be 11 times 10 to the minus 2 meters. Okay, next example. Convert 11 joules into kilojoules. And we're told kilo is 10 to the 3. We know we're working with joules, so let's write that down. And what's this say? It says 1 kilojoule is 10 to the 3 joules. Alright, so you start with your value that you want to convert, 11 joules, and multiply by 1. And of course we use a fraction equaling 1. Now, one of these is numerator, one is denominator, but which is which? Well, you want to cancel out joules, because that's 11 over 1, right? So you need joules. If joules is in the numerator, you cancel it by putting joules in the denominator. And you want to leave it with kilojoules in the numerator. So there we go. But my fraction is not yet complete because this doesn't equal 1 the way I've written it so far. So how do I make my numerator and denominator equal? Well, I look at my equation. The equation says 1 kilojoule, that's the left side, equals 10 to the 3 joules. The numerator and denominator are now equal according to the equation, and so I'm multiplying by 1, which is what we do when we convert. Now why did I put joules in the bottom? Because joules over joules equals 1, and so you don't have to write out times 1, you can just take out the joules altogether. So when you multiply this out, what do you have? You have 11 over 10 to the 3 times a kilojoule, so kilojoules is the unit. And if you want to, you can combine the powers of 10 here. So 11 is no different from 1.1 times 10 to the 1. You can bring that 10 to the 3 out of the denominator into the numerator. And when you do, you flip the sign of the exponent. So not positive 3, but now it's going to be negative 3 in the numerator times kilojoule. And when you have two powers of 10 multiplied together, you add the exponents. So what's 1 plus negative 3? It's negative 2. So the answer is 1.1 times 10 to the negative 2 kilojoules. Hey, that's fun! Right? No. Okay, let's try this one. This is fun. This is fun! It is very fun. And I think you're finding it fun. So I'm just gonna continue on. Fun! Okay, convert 11 centimeters into inches. Now this time, there's no prefix business, right? We're given the two units, centimeters and inches. Inches and centimeters. There they are. When the equation shows inches and centimeters, you know you can convert directly between inches and centimeters. You don't need to go through this business of converting centimeters to meters and 10 to the minus 2 like you saw in the last problem. You don't have to do that because you're already told how the two equate. Okay, that's great. So we can get rid of centimeters and change it into inches because we know how many inches equal how many centimeters. We can write a fraction equal to 1 straight away. What is that fraction? Well, 1 inch, the equation says 1 inch is equal to 2.54 centimeters. Do I have room? 2.54 centimeters. And now I've got a fraction equal to 1. Moreover, centimeters divided by centimeters is 1, so that goes away. Times 1, that's not necessary to write. And I'm left with inches, so I've gotten it right into what I wanted. So the answer is 11 over 2.54, whatever that is. You can work out on your calculator if you so desire. That many inches. Okay, finally, convert 11 centimeters into meters. Now, we're dealing with centimeters, into kilometers, not just meters, but into kilometers. So let's write centimeter is equal to 10 to the minus 2 meters. Kilometer is 10 to the 3 meters. Okay, and we start with what we want to convert. Now, do we have one equation that says this many centimeters, so many centimeters equals however many kilometers? Do we have that equation? No, we don't. One of the ways to answer this question is to construct an equation using these two equations, combine them into one equation containing centimeters and kilometers. You could do that if you want, or you can take a different approach, which is I'm going to show the other approach. You can multiply by 1 twice. Right? The first time I multiply by 1, right, I can't just go from centimeters and kilometers because I don't know what numbers to put here. I don't know how many centimeters equals how many kilometers. So instead of doing that, I'm going to go from centimeters into whatever I can get to. So what's my equation say? It says I can go from centimeters into meters. Okay? 1 centimeter is 10 to the minus 2 meters, according to the equation. So I am successfully multiplying by 1. Here's a fraction that equals 1 because the numerator and denominator are equal. Now, what's that do for me? Well, I'm canceling out the centimeters. The centimeters over centimeters is 1. And I'm left with just meters. So that would be 11 times 10 to the minus 2 meters. And then I can multiply by 1 again. And this time, I'm going to get rid of the meters. And hey, look at that. This equation tells me how to convert meters into kilometers. And after all, I want kilometers. So let's use this equation to convert from meters to kilometers. Remember, converting is multiplying by 1. So how do I make this fraction equal to 1? I need bottom and top to be the same, to be equal. The equation tells me how to make bottom and top the same. It says 1 kilometer, that's the left side of the equation, is equal to 10 to the 3 meters. 10 to the 3. Okay, why do I put my meters on bottom? Because meters divided by meters is 1. By putting meters on bottom, I get these meters to cancel out. And so what are you left with? You're left with 11 over 10 to the 3 times 10 to the 2, 10 to the minus 2. That many, and then times kilometers, so that many kilometers. Now if you combine your powers of 10, 11 is 1.1 times 10 to the 1. So you've got 10 to the positive 1, 10 to the minus 2, and then this would be 10 to the negative 3 when you bring it up. 1 minus 2 minus 3, that's 10 to the minus 4. 1 minus 2 minus 3 times the 1.1. So there's your final answer. Now the last thing I want to show, and you can stop the video if you don't want to do it this way. You don't have to do it this way. Okay. You come to this problem and you say, alright, I need an equation that relates centimeters and kilometers. Right? That's what you need, an equation telling how many of one equal how many of the other. So you specify the prefix to the particular case of meters. Right? Write that in. And then you use these to construct one equation with centimeters and kilometers. Right? So what's the one equation? Well, centimeter, 1 centimeter, is 10 to the minus 2 meters. Now, 1 kilometer is 10 to the 3 meters. Like that. Well, I could divide both sides. Well, I could divide both sides by 10 to the 2. In this 10 to the minus 2 in this first equation. So now I bring that 10 to the minus 2 up as positive, and I get this. The meters cancel out. I'm sorry, the 10 to the minus 2 cancels, leaving me just with meters. And then over here, I can divide both sides by 10 to the minus 3, 10 to the positive 3. And I've got, this comes up as a negative exponent. I flip the sign from positive to negative. So 10 to the minus 3 kilometers equals, these cancel, the 10 to the 3's cancel, and I'm left with just meters. So look at that. If this is equal to a meter, and that's equal to a meter, then these things are equal. So now I know what my equation should look like. I just take away the meters. Whoops. I take away the meters, and I set these two things equal to each other. Like that. Okay, now I can take my 11 centimeters, what the value that I'm converting, 11 centimeters, and I can multiply by one fraction. I can get rid of my centimeters, and I can change it into kilometers using this equation. How do I get my fraction to equal 1? Because after all, I'm converting. Got to multiply by 1. Well, how many centimeters and how many kilometers are equal? 10 to the 2 centimeters equals 10 to the minus 3 kilometers. So now my numerator and denominator are equal. I'm multiplying by 1. Centimeters divided by centimeters is 1, so multiplying by 1, I don't have to show that. And I'm left with this many kilometers, which gives the exact same answer as before. 10 to the, what was it, minus 4. So negative 3 minus 2 is negative 5. And then that's a positive 1 power of 10 here, so that's negative 4. Got to keep the units in there, can't forget that. And that's the final answer. So this method is just as acceptable. It's just as acceptable as the method I showed before. And just as acceptable as both of these is showing your conversion all in one step, multiplying by 1 twice in one step. So you could do centimeters and meters and say, okay, 10 to the minus 2 is equal to 1, and then convert meters, cancel out the meters, into kilometers, and say 1 kilometer, right, is 10 to the 3 meters. and get your answer this way. This is just as valid as all the other things I've shown, because the centimeters cancel, meters cancel, leaving kilometers. 3 different ways to do one problem.